So this project is Graphomer. That is, do transformers really perform bad on graph data? Here they have used tried to check whether transformer architecture can enhance the performance of a graph neural network on graph-based dataset. Till now, transformers are used for sequential data, and it has improved its worth on that particular data. But they want to check whether it can perform really well on graph data also. So this is the architecture they have used. So initially, the input for the molecule is taken as a node feature. Here, they have not mentioned much about the input and output format, but the input will be a node feature vector, and the output format will be an embedding that we get after the transformer. So they have used the classical transformer here. Along with that, they have used three different types of encoding. One is centrality encoding, that is used to store the in degree and out degree. So basically, centrality encoding is used to model the importance of a node. It uses degree centrality that stores for each node we stores one value, that is node in degree and out degree. Sum of both is connected to node feature, and then that is given as an input. Other encoding they have used is spatial encoding. For each node pair, they calculated the shortest path between them. And the third encoding is edge encoding, that for each node pair vi to vj, they take one of the shortest path between them and calculated the average, as they have given here, like calculate the average of dot products of edge features and the learnable embedding along the path. So this cij is added to the attention, this value. Here we can see that spatial encoding and edge encoding are added later, and then we applied the softmax here. So they have used these particular four data sets. So all these four data sets are this first one is the largest particular data set on graph, based on graphs. It consists of 3.8 million graphs, and they have shown the results also that it performed better than many state of the art neural networks on all these data set, and it is also the best data set for this particular open graph benchmark large scale challenge.
So the next section will be the code overview. So here you can find the GitHub repository link. The another thing is the Graphomer is just inherited over the FAIR sequential library, and we can extend this Graphomer based model to make different kind of model according to our requirements. So this is the file structure of only the Graphomer code in the wrapper present. So the first folder contains the code for loss functions that they have used. The second folder contains the code for the parsing and lookup table used for different datasets. So there they have mentioned the dataset, DLG dataset, OGB dataset, PYV dataset, and SMILES. And the third is the evaluation function code. And another they have mentioned the two type of model. One is 2D model and one is 3D model. So this file contains the architecture of both the models. And another the modules, which are different layers and components they have coded especially for the model architecture, and like multi-head attention, Graphomer's layers, and coded layers, etc. So the next section we move to is the command line tool. So this Graphomer gives us a command line tool so we can train different kind of models. Also, we can use the pre-trained models as per our requirements. So the command line tool is again the inherited from FAIR sequential module. So how to install this? So we have to first create a virtual environment. So because it is better, and you can simply like in pip install or conda activate Graphomers. You can just clone the Git repository and run this bash install.sh. That's all. Now, how to use the CLI? So the first is fine tune the pretrained model. So it contains some set of pretrained model, and we can fine tune them as per our requirements. So this is how we can use this. This is the command where you train, and these are the arguments it can take. There are different type of arguments. So what directory you have to use, how many workers are there, dataset name, and all these stuff. Similarly, you can also fine tune and evaluate the parameter, fine tune model using this function, this code, this command line code. Similarly, if you want to train a model from start, like first we can say is2re train model. So this is a command how to train the model, like the train model from scratch. And this is a command line tool to after generating the Graphomer architecture, how to run this. Now the next section we can discuss is the datasets. So the supported datasets in the CLI are three datasets: DGL dataset, PyTorch geometric datasets, and OGB datasets. Apart from this, like if you want to customize a dataset, like take only the part of the datasets which the dataset already contain, you can use this type of code. So simply create a customized dataset function, pass different type of split ratio, and that's it. It will generate the new dataset, and you can use it in the CLI as well. Yeah. So this is how you can use this CLI presented by the Graphomer to train different models and use a pre-trained model as well. Since our project code did not contain any example or task of the code where you can test it, hence we have made this report. So yeah, that's it. Thank you.